A voltage tripler is an advanced electronic circuit designed to significantly increase the voltage level of an alternating current (AC) signal through a three-stage process of rectification and voltage multiplication. This sophisticated circuit utilizes capacitors and diodes strategically to accomplish the task of transforming a lower-value AC input into a higher-value DC output. The fundamental principle behind the voltage tripler lies in the combination of capacitors and diodes, working in tandem to perform both rectification and multiplication of the input voltage. The tripler consists of three distinct stages, each contributing to the overall process of elevating the voltage level. Stage 1. Charging capacitor C1 with negative peak of input voltage, Vm. During the negative peak of the input AC voltage, the diode D1 conducts, allowing capacitor C1 to charge to a voltage equal to the peak value of the input signal, denoted as Vm. This initial charging sets the foundation for subsequent stages in the voltage tripler circuit. Stage 2. Adding voltage with positive peak of input voltage plus Vm. As the input AC voltage transitions to its positive peak, the voltage stored in capacitor C1 combines with the input source, charging capacitor C2 to twice the peak value of the input voltage, i.e., 2 Vm. Diode D2 facilitates this process, ensuring the unidirectional flow of current and accumulation of charge on capacitor C2. Stage 3. Charging capacitor C3 with second negative peak, Vm. Following the completion of the second stage, capacitor C1 discharges to 0 volts during the second negative peak of the input voltage. This allows capacitor C3 to charge through diode D3, reaching a voltage of 2 Vm. The capacitor C3 now holds a voltage equal to that of the second negative peak of the input signal. Stage 4. Repeating the process with second positive peak plus Vm. During the second positive peak of the input AC voltage, capacitor C2 undergoes a similar charging process as in the second stage, achieving a voltage of 2 Vm. Simultaneously, capacitor C4 is charged to the same voltage, as diode D4 facilitates the flow of current. Consequently, the total output voltage is the sum of the voltages across capacitors C2 and C4, resulting in an output voltage of 4 Vm. The voltage tripler, as the name implies, extends this process to 3 stages. It employs 3 capacitors and 3 diodes, creating a more intricate circuit compared to simpler voltage multiplier configurations. The arrangement of capacitors and diodes in the tripler circuit ensures a step-by-step multiplication of the input voltage, with each stage contributing to the overall amplification. The tripler's output DC voltage is approximately 3 times the maximum value of the input AC voltage. This remarkable voltage multiplication capability makes the voltage tripler a popular choice in various applications where a higher DC voltage is required. In summary, the voltage tripler is a sophisticated electronic circuit that employs a carefully orchestrated sequence of capacitor charging and discharging, along with diode rectification, to achieve a threefold increase in the input AC voltage. This advanced voltage multiplier configuration finds utility in scenarios demanding elevated DC voltages, showcasing the ingenuity of electronic circuit design in power supply applications.